Hello students, today we are moving on to the last topic of the fifth module, residue integration. Now the last topic is evaluation of improper integrals. We have to study two types of problems in this topic. Type 1, integrals of the form integral over 0 to 2 pi f of cos theta sin theta d theta. This is type 1 problem. How we solve this type of problem? Look at this. Here we are given a contour. We consider a contour modulus of z is equal to 1. In this type we consider the contour modulus of z equal to 1. Then we know that z equal to e raised to I theta. Okay, we know that z equal to e raised to I theta. Then dz is equal to e raised to I theta into I d theta. Taking the derivative of e raised to I theta, we get e raised to I theta into I d theta. And from this we can write d theta equal to dz by I into e raised to I theta. Dz by d theta is equal to dz by I into e raised to I theta, but this e raised to I theta is nothing but z, so we write dz by iz. So d theta is equal to dz by iz. Okay. Now we also know that cos theta is equal to e raised to I theta plus e raised to minus I theta by 2. This is the formula for cos theta, but e raised to I theta is z and e raised to minus I theta is 1 by z. So we are writing cos theta equal to 1 by 2 into z plus 1 by z, and on simplifying we get z square plus 1 by 2z. Here the LCM is z, taking LCM, here z square plus 1 by z, and also this 2 is here, so z square plus 1 by 2z is cos theta. So we convert theta into z. That is our first step. So converting theta into z, we are given a question of type cos theta and sin, including cos theta and sin theta. We convert this theta into z using these formulas. Now this is cos theta. Cos theta equal to e raised to I theta plus e raised to minus I theta by 2. Then what is sin theta? Here sin theta is, now sin theta is equal to, what is sin theta? E raised to I theta minus e raised to minus I theta divided by 2i. This is sin theta, formula for sin theta, and this is equal to 1 by 2i into z minus 1 by z, and this is equal to, taking LCM we get here z square minus 1 by z, and this is equal to z square minus 1 by 2iz. So this is sin theta and this is cos theta, and d theta is d theta is dz by iz. On substituting all these in this, we get integral 0 to 2 pi f of cos theta sin theta d theta becomes integral over c. C is modulus of z equal to 1. We are given a unit circle. Modulus of z equal to 1. That is c. Integral over c f of, what is cos theta? Cos theta is z square plus 1 divided by 2z, and sin theta is z square minus 1 by 2iz, and d theta is dz by iz. And then after getting this, using Cauchy's residue theorem, we can integrate this function. Okay. So this is the procedure for finding integral over 0 to 2 pi f of cos theta sin theta d theta. Now we shall do some problems. Okay. Now look at this question. Evaluate integral over 0 to 2 pi d theta by 2 plus cos theta. So first we have to convert this theta to z using our formula. So here we are considering unit circle. This type of problem we take the unit circle. So consider the unit circle. The unit circle, modulus of z is equal to 1. Okay. Now we are given cos theta. So we have to write the formula for cos theta only. So what is cos theta? Therefore what is z? I am writing z here. Z equal to e raised to I theta, and dz equal to d theta, e raised to I theta into I d theta, and therefore d theta is equal to dz by iz. First result we are applying d theta Here d theta is equal to dz by iz. Now what is cos theta? Cos theta is equal to z square plus 1 by 2z. This is cos theta. So I am rewriting this function as now integral over 0 to 2 pi d theta divided by 2 plus cos theta becomes integral over c. C is modulus of z. You consider the unit circle c comma mod z equal to 1. So integral over c. What is d theta? D theta is dz divided by iz. The whole divided by 2 plus cos theta is z square plus 1 divided by 2z. Z square plus 1 divided by 2z. Now we have to simplify this. Look at this. This is equal to integral over c dz by iz the whole divided by taking LCM. Here the LCM is 2z and multiplying 2z with this 2 we get 4z. That is 4z plus z square plus 1 divided by 2z. Okay. Integral over c dz by iz the whole divided by 4z plus z square plus 1 divided by 2z. Now this is equal to integral over c dz by iz into taking the reciprocal we get 2z divided by z square plus 4z plus 1. Cancelling this z and 2 by I is a constant. I am taking outside 2 by I into integral over c dz divided by z square plus 4z plus 1. So this is equal to 2 by I into integral over c f of z dz, where f of z equal to, what is f of z? F of z equal to this function 1 by z square plus 4z plus 1. Okay, f of z is equal to 1 by z square plus 4z plus 1. So this is f of z. Now what is the integral of this function? Integral over c f of z dz using Cauchy's theorem, that is 2 pi I into sum of the residues. So this is equal to 2 by I into 2 pi I into sum of the residues. Sum of the residues. Okay, this is equation number 1. Let it as equation number 1. Now we have to find out the poles of this function. How we find out the sum of the residues? First we have to find out the residues. For that we have to find out the poles. Okay, so for poles we have to put this denominator as 0 and find out the values of z, that is roots of z. We get the poles and we have to find out how many poles are inside our circle and we have to find out the residues of that poles. Okay, let's do. Now for poles, now for singular points, we have z square plus 4z plus 1 is equal to 0. That is z is equal to minus b, that is minus 4. We have to use the formula minus 4 plus or minus root of b square is 16, b square minus 4ac, 4 into 1 into 1, that is b square minus 4 divided by 2a, that is 2. This is equal to minus 4 plus or minus, what is the square root of 16 minus 4 is square root of 12 divided by 2. And this is equal to minus 4 plus or minus root 12 is, what is 4 into 3? That is 2 root 3. 2 root 3 divided by 2. Okay. Now this is equal to, taking 2 as common, we get minus 2 plus or minus root 3. So this is the two poles, minus 2 plus root 3 and minus 2 minus root 3, we get 2 poles. Now we have to find out these poles, either these poles are inside or outside our contour mod z equal to 1. Okay, now first when z is equal to minus 2 plus root 3, we have modulus of z is equal to modulus of minus 2 plus root 3. modulus of minus 2 plus root 3. This is equal to, what is root 3? Value of root 3 is 1.73. So this is modulus of minus 2 plus 1.73. And this value minus 2 plus 1.73 is always less than 1. Okay? Always less than 1. So this point is inside less than 1. What is equal to less than minus 2 plus 1.73. Difference between these two values is always less than 1. Okay? So this is less than 1. So this point, this pole is inside our circle, comma, inside our circle. Inside C. So is equal to minus 2 plus root 3 is inside C. Now we have to find out whether minus 2 minus root 3 is inside or outside our circle. Now Z is equal to minus 2 minus root 3 implies modulus of Z is equal to modulus of minus 2 minus root 3. And this is equal to modulus of minus 2 minus 1.73, and this is equal to modulus of minus 3.73, which is equal to 3.73, which is always greater than 1. So this point is inside C and this point minus 2 minus root 3 is outside C, comma, outside C. So we get only one singular point or only one pole inside our circle, mod Z equal to 1, and we have to find out the residue at the pole minus 2 plus root 3. Now I am going to find out the residue at this point. Now residue of f of Z at Z is equal to minus 2 plus root 3. Also, what is the order of these two poles? These two poles are simple poles. Okay, both these poles are simple poles. So I am using the formula G of Z divided by H dash of Z for finding the residue. So G of Z divided by H dash of Z at the point Z is equal to minus 2 plus root 3. And this is equal to, what is G of Z? G of Z is the numerator of f of Z, that is 1, divided by H dash of Z. H dash of Z is derivative of the denominator. Our denominator is Z square plus 4Z plus 1. This is H of Z. So we have to find out the derivative of this H of Z, and derivative is 2Z plus 4. At the point Z equal to minus 2 plus root 3. Now I am putting Z equal to minus 2 plus root 3 in this term, and we are getting this is equal to 1 by 2 into minus 2 plus root 3 plus 4. This is equal to 1 by minus 4 plus 2 root 3 plus 4. And minus 4 plus 4 get cancelled and we get 1 by 2 root 3. So this is the residue at the pole Z equal to minus 2 plus root 3. Now we have to substitute, only one pole is here inside C, so only one residue. Now we have to put this value in equation number 1. Therefore, equation 1 becomes integral over 0 to 2 pi d theta divided by 2 plus cos theta is equal to 2 by I into 2 pi I into sum of the residues is 1 by 2 root 3. 1 by 2 root 3, and this is equal to 2 get cancelled and we get 2 pi I divided by, I also get cancelled and we get, this is equal to 2 pi by root 3, and this is the final result. So what is the procedure? First we have to find out d theta and the formula for cos theta in terms of Z. We get d theta equal to dz by IZ and cos theta equal to Z square plus 1 by 2Z, and we substitute all these in our question and we convert the function from theta to the variable Z. And now we use the Cauchy's residue theorem. For that we find out the poles and residues, and finally we use the Cauchy's residue theorem to find out the final answer, find out the integral. Okay, thank you.